Hi, in this AV we are going to solve the numericals of the chapter Laws of Motion, and we will be talking about exercise 3C. From this exercise, the first question says a body of mass 5 kg is moving with velocity 2 meter per second. Calculate its linear momentum. So as we have been doing, first we'll write the given things. So given, we have the mass m to be equal to 5 kg. After that, we have been provided with the velocity. So velocity v is equal to 2 meter per second. So now we will write using the formula, or we know that momentum or linear momentum that we have to find, linear momentum P is equal to the product of mass and velocity. So we have the values, we will simply put it. 5 into 2, we have 10 kg meter per second. So the linear momentum is 10 kg meter per second. This is the answer. Now we go to question number 2, which says the linear momentum of a ball of mass 50 gram is 0.5 kg meter per second. Find its velocity. So here we will be using the same formula, but instead of P we have to find V. So we write the given things. So here we have written the given things, that mass is equal to 50 grams. We know that SI unit of mass is kg. So we have converted it into kg by dividing it by 1000. Then linear momentum is given to be 0.5 kg meter per second. So now we write the formula that we are going to use. So linear momentum is equal to the product of mass and velocity. But we have to find the velocity. So we will convert it in terms of velocity. So we know V will be equal to P upon M, that is linear momentum divided by mass. We have the values, we will simply substitute it. So 0.5 divided by 0.050, and after division, when you remove the points and all, then you will get 10 meter per second. The SI unit of velocity is meter per second. So again you will be writing like this, the final statement, that the velocity of the ball is 10 meter per second. Now we go to the next question, that is question number 3, which says a force of 15 Newton acts on a body of mass 2 kg. Calculate the acceleration produced. So here again we will write the given things. We know that the equation which relates force, mass and acceleration is the second law, which states force is equal to mass multiplied by acceleration. But here, or we write F is equal to ma. So we have to find the acceleration, that is a. So we convert this equation in terms of a. So a will be equal to F upon m. We have the value of F to be 15 Newton and mass is 2 kgs. So after division, we will get 7.5, and the SI unit is meter per second square for the acceleration. So therefore the acceleration produced is 7.5 meter per second square. After this, there are similar questions which you can use the same equations and find out the answer. So we go to question number 7, which states a force acts for 10 seconds on a stationary body of mass 100 kg, after which the force ceases to act. The body moves through a distance of 100 meter in the next 5 seconds. So this time is important. Calculate first of all the velocity, then the acceleration, and finally the magnitude of the force. So we will write the given things first. So here we have written the given things. The time for which the force acts is 10 seconds. Mass of the body m is 100 kg and distance through which the body moves is 100 meters, and the time for which the body moves is 5 seconds. So this time is important for us. So trying to find the first part of the question, which states we have to calculate the velocity acquired. So the body moves a distance of 100 meters in 5 seconds. So therefore velocity is equal to distance covered upon time taken. In this case, generally we say that velocity is equal to displacement upon time, but in this case distance and displacement will be the same. So we are writing distance upon time. You can write displacement also, no harm. So putting the values, we know that distance is 100 meters. So we write 100 meter divided by time taken is 5 seconds. So after division we will get 20 meter per second. So you can write one line that the velocity that the body will acquire is 20 meter per second. The next part of the question is we have to find the acceleration produced. So we can simply write using the third equation of motion. The third equation of motion is v square minus u square is equal to 2as. Final velocity square minus initial velocity square is equal to 2 multiplied by acceleration multiplied by the distance moved. So we have to find the acceleration. So we convert this equation in terms of acceleration. So acceleration from here would be v square minus u square upon 2s. So now we will simply put the value. So after we put the value, we will get a is equal to, that is acceleration is equal to velocity square. So velocity is, here it's given in the question, we have found out 20 meter per second. So 20 square minus, since the body was stationary, so initial velocity would be 0 divided by the time for which it moves, the distance through which it moves. So 2 into s. S is the distance moved, that is 100. So 20 square will be 400 divided by 200. After division you will get acceleration to be 2 meter per second square. You can please write one sentence that the acceleration produced in the body is 2 meter per second square. And finally the third part of the question, which asks us to find the force. So we know, or from Newton's second law of motion we know, that force is equal to mass into acceleration. So we just put the value of mass, that is 100 kg, multiplied by acceleration we have just calculated to be 2 meter per second square. So multiplied by 2, this gives us 200, and the unit of force is Newton. So we find the answer, and you can just write that the force or the magnitude of the force is nothing but 200 Newton. Now after this we go to the next type of question, that is question number 9, which says a force causes an acceleration of 10 meter per second square in a body of mass 500 grams. What acceleration will be caused by the same force in a body of mass 5 kg? So force remains the same. Then if the mass of the body changes, what will the acceleration produced be? So here we first write the given things. So here we have written the given things. Acceleration is 10 meter per second square. Mass of the body is 500 grams. We know that the SI unit is kg for mass. So we divide it by 1000 and convert it into kg. And we get 0.5 kg. So we say that let F be the applied force which is being applied. So after applying this force, we get the acceleration of 10 meter per second square. So now we will find out what is the value of force. So using the equation, force is equal to mass into acceleration. We have the mass 0.5 kg multiplied by acceleration produced is 10 meter per second square. After multiplication we will get 5, and the unit of force is Newton. So this force will again be applied on a mass of 5 kg, and we have to find out what will the acceleration be. So let's write the new acceleration. Let A prime be the acceleration produced on the body of 5 kg. So here the force is 5 Newton. So again we know F, here we will take F prime, sorry, force remains the same, so we can just take F. F is equal to mass into acceleration. So mass has changed, so we will just put it as prime, and acceleration will change, so we will put it as m prime a prime. Now we need to find out the acceleration factor. So we will first write this equation in terms of a prime. So a prime, that is acceleration, new acceleration will be force upon the new mass. We know that the force is 5 Newton and mass is also 5 kg. So our new acceleration, or the acceleration produced in the body of 5 kg, mass 5 kg, will be nothing but 1, and the unit is meter per second square. Now we go to the next question, that is question number 10, which states that a force acts for 0.1 second on a body of mass 2 kg. Initially at rest, the force is then withdrawn and the body moves with a velocity of 2 meter per second. Find the magnitude of the force. So we just have to find the magnitude of the force, and they have given us the mass of the body, the initial and the final velocity, and the time. So first of all we write the given. So here we have written the given things, that time is equal to 0.1 second, mass is 2 kg. Initially it was at rest, so initial velocity is 0 and final velocity v is 2 meter per second. Now we know that force is given as mass into acceleration, but here we have not been provided with the value of acceleration. Rather we have been given the initial velocity, final velocity, and time. So using that we can find out the acceleration. We know that acceleration formula is final velocity minus initial velocity upon time taken. So this equation we will substitute in place of acceleration. So this equation looks like force is equal to mass multiplied by final velocity minus initial velocity upon time taken. So now we have all these values and we simply substitute it. So mass is 2 kg multiplied by final velocity is 2 meter minus initial velocity is 0 divided by time is 0.1 second. So after simplifying and calculating it, we will get 4 divided by 0.1, or we can say 40 Newton is the required magnitude of the force. So you can simply write one line, the magnitude of the force is 40 Newton. Now we try question number 12, which says a car of mass 480 kg moving at a speed of 54 km per hour is stopped by applying brakes in 10 seconds. Calculate the force applied. So either we can use the formula F equal to ma, for which we will need to calculate acceleration separately. In this case it will be retardation because the brakes are applied. Or you can do it in a single equation like we did in the last or the previous one, that force is equal to m, and instead of acceleration you write the formula for acceleration v minus u upon t. So let's write all the given things, and one thing we have to check here, the speed is given as 54 km per hour. So this will be, we will need to convert it into meter per second by dividing it, multiplying it by 5 by 18. So here we have written the given things. Mass is given to be 480 kg. Initial velocity u is given as 54 km per hour. So here we convert it by into meter per second by multiplying it by 5 by 18. This is a shortcut, and then we get it to be 15 meter per second. Now finally the car is coming to rest after the brakes are being applied. So final velocity is 0, and for which the time is taken as 10 seconds. Now as I told you, we have to find out force. So we know force is equal to mass into acceleration, but here acceleration is not being given to us. So either you can put the value of or the formula for acceleration here itself in the same equation and put the values and find out the answer, or you can calculate acceleration separately and then put it in this equation and find the value of force. I'm going to put it in the same equation. So we know acceleration is given by final velocity minus initial velocity upon time taken. So mass is given as 480 kg, and then we have final velocity, which is 0, minus initial velocity is 15 divided by the time taken, that is 10 seconds. So when you calculate this part first, 0 minus 15 is minus 15 upon 10. So here the minus sign will only indicate that this is a negative acceleration or retardation or deceleration. So this 480 multiplied by, here we will get 15 divided by 10 is minus 1.5. So this negative sign indicates retardation. So we can just ignore it. We will just know that negative sign means retardation, and for finding out the value of force, we will simply multiply these two numbers and we will ignore the minus sign. So force is equal to 480 multiplied by minus 1.5 or 1.5, but we will ignore the minus. So after multiplication you will get it to be 720, and the SI unit of force is Newton. So you can just add one more line that the force applied is 720 Newton. Finally we come to question number 13. This will be our last question in this AV. So this question says a car is moving with a uniform velocity of 30 meters per second. It is stopped in 2 seconds by applying a force of 1500 Newton through its brake. Calculate the change in momentum of the car, the retardation produced, and the mass of the car. As usual, first we will write the given things. So here we have given the we have written the given things. That is, initial velocity u is 30 meters per second, final velocity is 0 because the car is coming to the rest, and time t is equal to 2 seconds, and force applied is 1500 Newton. Now first of all we have to find out the change in momentum. So we know that for finding out change in momentum, we have the formula is final momentum minus initial momentum. For both final and initial momentum we need to know the mass. So mass will be calculated from the formula force is equal to mass into acceleration. Now for using that formula we have to find out the acceleration first. So let's find out the acceleration first. So here in this case acceleration is equal to v minus u upon t. So we know that finally the car is coming to rest. So 0 minus initial velocity is 30 and the time taken is 2 seconds. So again it will be minus 15 meter per second square, and this minus sign again indicates that this is retardation. So when we use it for the formula force is equal to mass into acceleration, we will neglect the minus sign. Again we know that force is given as mass into acceleration, and we have to find the mass from here. So we will rewrite this equation in terms of mass. So mass will be equal to force upon acceleration. So we know that the force is 1500 Newton divided by the acceleration we have calculated to be 15 meter per second square. So 1500 divided by 15. After this we will simply get, we can write it here, 100 kg. So we have calculated the mass. Now we can find out the change in momentum. So the first part of the question says we have to find the change in momentum. So change in momentum is final momentum minus initial momentum. So final momentum minus initial momentum. So we know the formula for final momentum, it's m cross final m multiplied by final velocity, and for initial it is m, that is mass multiplied by initial velocity. So from these two we can take mass common, and we will have the final velocity minus the initial velocity. We have these values, we have calculated mass here, it comes out to be 100 kg. So instead of mass I am going to write 100, and final velocity is 0 minus initial velocity is 30. Now again here we are going to get it in terms of minus. As I told you, we will ignore the minus because this minus, what we get here simply means retardation. So finally the change in momentum would be 3000 kg meter per second. For the second part of this question, it asks us B, the retardation produced. So for retardation, you can simply rewrite this part, that we know force is equal to mass into acceleration, and from here we can we have calculated the retardation here. So you can simply write this, and you can say that the negative sign indicates retardation. And the third part, or part C of the question, asks us to find the mass of the car. Mass also we have already calculated here, so you can simply rewrite this part and say that mass is equal to, or mass of the car is equal to 100 kg. That's all we have in this AV. Thank you so much.